All right, today we're pulling back the curtain on one of the coolest things happening in AI right now. It's called Retrieval-Augmented Generation, or RAG for short. And honestly, it's the secret engine that's turning these kind of creative, sometimes unreliable language models into actual fact-checked powerhouses.
So, to really wrap your head around RAG, you've got to understand the huge problem it's built to solve. You see, even the biggest, baddest AI models have this issue. Researchers call it hallucination, and it's exactly what it sounds like. The AI, trying its best to answer you, just makes stuff up. It sounds super confident, totally plausible, but it's just plain wrong. And that is the massive challenge RAG steps in to fix.
Here's a great way to think about it. A standard LLM, it's like it's taking a closed book exam. It can only use what it crammed into its memory during training, which happened a long time ago. But an LLM with RAG, that's a whole different ballgame. It's like it gets an open book exam. It can look stuff up, access a whole library of current, real-world info, and ground its answers in actual facts, not just old memories.
Okay, so this open book exam idea sounds great, right? But how does it actually work? What does it look like for an AI to have, an external brain?
Well, the clue is right there in the name, Retrieval-Augmented Generation. So before the AI even thinks about generating an answer, it first does something crucial. It retrieves relevant info from an external knowledge base. You can think of this like a super specialized library, or maybe an external hard drive plugged right into the AI's brain. It's giving it access to way more stuff than it was ever trained on.
And the process itself is actually this really elegant three-step dance. It's pretty straightforward. Step 1, you ask a question. Step 2, the retriever gets to work zipping through its knowledge base, which is usually a super fast vector database, and pulls out the most relevant little chunks of info. And then, step 3, it bundles your original question together with all that fresh context it just found and hands the whole package over to the LLM. The result? A smart, context-rich, and fact-checked answer. Ask, find, answer. So simple, but wow, is it powerful.
Of course, it's never that simple, is it? As soon as developers started building with this incredible tech, they hit a wall. It turns out that even with an open book, you can still totally bomb the test.
Yeah, people in the real world hit some serious snacks. For one, sometimes the whole thing was just painfully slow. Or worse, the retriever would go and grab completely irrelevant stuff. Imagine asking a librarian for a book on quantum physics, and they hand you a cookbook. That's what was happening. And on top of that, you had huge security concerns, like the system accidentally spitting out sensitive, private information. These weren't just little bugs. They were major, fundamental roadblocks that had to be fixed.
But you know what happens when smart people face tough problems, right? It sparks a ton of innovation. All these challenges basically kicked off a new wave of research, creating a whole new generation of advanced RAG techniques, each one designed to tackle a specific flaw and, well, supercharge the whole system.
So the first big breakthrough was kind of a head-scratcher. People realized that a lot of the time, the problem wasn't that the answer was missing. The answer was right there in the data. The real issue was that the way we ask questions is just really different from the way answers are written.
And this is where a really clever technique called hide comes into play. It completely flips the script. Instead of searching for the user's question, hide does something wild. It tells the AI, hey, just invent a perfect hypothetical answer to this question. Then, it takes that fake answer and uses it to search for real documents that look similar. It's this amazing paradox. By searching for a made-up answer, it does a way better job of finding the real one. Okay, so hide is awesome. We're finding much better documents now. But there was another big problem. See, traditional RAG looks at all this information as just a bunch of separate, isolated facts. It's like it might know that Company A bought Company B, and it might know that Company B is based in California, but it doesn't automatically connect the dots and understand what that means.
This is where Graph RAG comes in, and this is a game changer. It upgrades the knowledge base from just a pile of documents to a structured knowledge graph, basically a web of interconnected ideas. The social network analogy is perfect here. It's the difference between reading a few random diary pages versus seeing a character's entire family tree and social circle. Suddenly, the AI can see the relationships between things, allowing it to reason in a way more sophisticated way.
All right, so now RAG is smarter, its reasoning is deeper. But we've got a new problem, a big one. Running these massive AI systems costs a fortune. So the next big leap forward had to be about efficiency. How do we get all this power into something smaller, faster, and frankly, cheaper?
And the solution here is really clever. It's a technique called DRAG, which stands for distilling RAG. The best way to picture it is to imagine this giant, super smart teacher AI, and it's training a smaller, more nimble student AI. The teacher basically shows the student the ropes, passing on all its wisdom and reasoning skills, but without all the massive computational baggage. It's like a brilliant professor writing the perfect textbook for their star student.
And you know what? The results are, well, they're seriously impressive. You can see here that models we already know, like Llama and Quen, got a huge boost in their performance. We're not talking about a tiny little improvement here. This is a massive leap forward for these smaller, more efficient models.
In fact, check this out. The research shows that drag can beat other methods by nearly 28% using the exact same models. That is a ridiculous gain in both efficiency and accuracy. It really proves that bigger isn't always better.
Okay, so let's recap. We've got smarter retrieval, deeper reasoning, and now much better efficiency. But what happens when you put all of these pieces together? Well, you get something really powerful. You get the next evolution of RAG. And that future is something called agentic RAG. This is where we move away from RAG being just a passive tool that follows orders. The new frontier is an active decision-making system. An agentic RAG can look at a tough question, realize, hey, I'm missing a piece of the puzzle here, and then figure out on its own how to go find that missing piece. We're moving beyond an open book exam. This is like having an intelligent, autonomous research partner.
And that's really the key takeaway here. We're watching a fundamental shift happen in real time. We're going from AI systems that just passively fetch information to systems that can actively reason and explore. So think about it. When an AI can spot the gaps in its own knowledge and then go figure out how to fill them, what kind of problems does that suddenly make solvable? We're talking about tackling complex scientific research, maybe diagnosing incredibly rare diseases, or even untangling complex financial crimes. The possibilities are just huge. The big question is shifting from what does the AI know to what can it figure out on its own.